Hey there, welcome to a deep dive all about Docker. Seems like you've got a pretty big stack of resources about it, which makes me think you're really interested in seeing what it can do, for getting those applications up and running quickly and easily.
Yeah, well, it's pretty amazing, right, how Docker has just kind of taken the tech world by storm.
Yeah, it's really become quite a thing.
Yeah, it's not just like some new tool. It's like a whole new way of thinking about how we develop and deploy software.
Absolutely. And right at the center of it all is this whole idea of containers.
Right.
The resources that you sent over mention this analogy of a container being like a ship.
Okay.
I'd love to hear what you think about that. Like, how does that analogy help us understand what Docker is all about?
That's a really great analogy. Think about it, like a container ship carrying everything it needs to function, across the ocean.
Yeah.
Like the fuel, the crew, supplies.
Makes sense.
And in the same way, a Docker container, it holds everything that your application needs to run. The code, the libraries, all the dependencies. It's all bundled up neatly
Oh, cool.
and ready to just go anywhere.
Okay.
That's what makes your application portable.
Yeah.
You can build it once and run it anywhere.
Oh, nice.
And that eliminates those dreaded "it works on my machine" issues that we all know and hate.
Yeah, for sure. So it's like giving your application its own little self-contained world.
Exactly.
Right. And this world can be shipped to any machine that is running Docker without even having to worry about any compatibility issues.
Exactly.
Oh,
And because these containers, they share the host operating system's kernel,
okay.
they're so much lighter and more efficient than those traditional virtual machines.
I see.
You can spin up containers much faster using fewer resources.
That makes sense.
Yeah.
Now, the resources I have here, they mention some key Docker concepts. I've got Docker images, repositories, and registries.
Right.
Can you break those down for me?
Of course. So a Docker image is basically a blueprint for creating a container. It's a read-only template that contains everything your application needs. So think of it like a master copy.
Got it. So the image is the blueprint.
Yeah.
Then what are these repositories?
Docker repositories are like namespaces or like folders on your computer where you store these images.
Okay.
They help you to organize and manage all of your images.
Right. So I create my awesome application image. I store it in a repository. But where do these repositories actually live?
That's where Docker registries come in.
Okay.
They're like online hubs
Oh, okay.
where you can store and share your Docker images.
Gotcha.
Docker Hub is probably the most well-known public registry,
Right.
but you can also have you can also create private registries for your own organization.
So it's a bit like GitHub, but for Docker images.
Exactly. It really enables collaboration
Yeah.
and just efficient sharing of application environments.
This is really giving me a much clearer picture of how Docker really just simplifies the whole development and deployment process.
All right.
Now, how do I actually get these images up and running? The resources mention a bunch of Docker commands.
You're right, there are a bunch of commands.
Yeah.
To get started, you'll need to know commands like Docker, pull to download an image from a registry,
Okay.
Docker build to create an image from a Docker file, and Docker run to launch a container from an image.
Right, and there are more, right?
Yeah, oh yeah.
Like it seems like there's a Docker command for just about every action.
There is, pretty much.
From stopping and removing containers to committing changes and pushing images to registries.
Right.
It's like a whole new language.
Yeah, it's a lot at first,
Okay.
but the basic commands are actually fairly straightforward.
Oh, okay.
Once you grasp those, you'll have a remarkable level of control over your containers.
Speaking of control, let's talk about Docker files.
Okay.
They seem to be the key to customizing application environments.
Right.
What can you tell me about them?
A Docker file is basically like a recipe for your Docker image.
Okay.
It's a text file with step-by-step instructions.
Yeah.
That Docker uses to build that image.
Okay.
You specify things like what base image to start with, what commands to run during the build process, what files to copy, and much more.
Wow.
It's all defined in a simple, human-readable format.
So if I wanted to create an image that includes a very specific version of a library
Right.
or a custom configuration file, I could define all of that in my Docker file.
Exactly. Docker would then take care of executing those instructions
Oh, cool.
and building the image accordingly.
Yes,
This level of automation is a huge time saver
I bet.
and reduces the potential for errors.
Yeah, that's got to be helpful.
Big time.
The materials I've got here dive into some common Docker file instructions like from, run, copy, workdir, cmd, and entry point.
Right.
Can you give me an example of how those instructions work together to build an image?
Sure. Let's say you're building a simple web application
Okay.
using Python and Flask.
Okay, cool.
You'd start your Docker file with the from instruction,
All right.
specifying a base image like Python 3.9. This tells Docker to use an official Python 3.9 image as the foundation.
Okay, so you're building upon an existing image,
Right.
inheriting all the tools and libraries that come with it.
Exactly. Then you might use runn to execute commands within the image,
Okay.
like installing Flask and other dependencies using pip.
So run lets you execute any command you would normally run on the command line,
Huh.
but within the context of the image you were building.
Exactly.
That's neat.
Next, you would probably use copy to copy your application source code
Okay.
from your local machine into the image.
Got it.
And workdir sets the working directory inside the image
Right.
where your application code is.
So it's like setting the stage for your application to run.
Exactly.
Gotcha.
And then finally, you would use cnd or entry point to specify the command that should be executed when the container starts,
Right.
which would probably be the command to launch your Flask application.
This is really fascinating. By writing these instructions in a Docker file, we can automate the entire process of building an image that contains our application
Yes,
and everything that it needs to run.
exactly.
And that's just the beginning, right?
It's just scratching the surface. Docker files can get way more complex,
Wow.
allowing you to define multi-stage builds for optimized images,
Huh?
utilize build arguments for customization, and much more.
It sounds like Docker files provide such a powerful and flexible way to build those custom images tailored to your specific needs.
Right.
And then with registries, you can easily share these blueprints with others.
Yeah,
And it just fosters collaboration and efficiency.
you got it. Docker is so much more than just containers.
Yeah.
It's an entire ecosystem for building, sharing, and managing them.
This is making a lot of sense.
Good.
What's next in our exploration of Docker? What other powerful tools and techniques should we be aware of? Okay, so we've talked about the basics of building images with Docker files.
Right.
But what happens when you have multiple containers that need to work together? Like, how do they communicate, share data, and function as like a cohesive application?
Right.
That's where things get really interesting.
You're absolutely right.
Yeah.
Managing individual containers is one thing,
Mm-hmm.
but when you start talking about orchestrating them into a real functional application,
Yeah.
that's a whole other challenge.
Right.
And that's where concepts like container networking, data volumes, and Docker Compose really come to play.
The resources you sent me touch on container networking.
Yeah.
Why is it so important for containers to be able to talk to each other and the outside world?
Well, imagine you're building a web application
Yeah.
with a separate front end, back end, and a database.
Yeah, sure.
These components need to be able to communicate seamlessly
Right.
to function as a unified application.
Okay.
Docker provides like a virtual bridge network by default,
Okay.
allowing containers on the same host to communicate
Yeah.
using their own internal IP addresses.
So it's like each container has its own little address within this Docker network.
Right.
So they can exchange information without any interference from the outside world.
Exactly. And it goes beyond just, like basic communication.
Oh, wow.
You can create custom networks,
Really?
connect containers to external networks,
Wow.
and even control how traffic flows between containers
Okay.
using, more sophisticated routing rules.
So it's a whole networking layer built just for managing communication
It is.
within and between containerized applications.
Exactly.
That makes a lot of sense.
Yeah.
This level of control over container networking has got to be like a dream come true for system administrators and network engineers.
It's a game changer.
Yeah, I bet.
Yeah, it offers just incredible flexibility
Yeah,
and a granular level of control,
right.
which you can't get with those traditional virtual machines.
Right. Another concept that I thought was really cool was data volumes.
Yeah.
Why is persisting data outside of containers so important?
You have to think about it this way. A container, it's ephemeral.
Okay.
If you stop or delete a container,
Right.
all the data stored within it disappears.
Oh, wow.
And this is a huge problem for
Yeah.
applications that rely on persistent data, like databases or user-generated content.
So if my database is running inside a container
Right.
and that container fails,
Yeah,
I lose all my data.
you got it.
That's not good.
That's a nightmare.
Yeah.
But data volumes come to the rescue
Okay.
by letting you mount directories from the host machine into a container.
Okay.
So it's like you're creating an external hard drive
Right.
that the container can access.
Yeah.
Even if the container is deleted,
Yeah.
the data is still there, safe and sound on that host machine.
That's a really clever solution
Yeah.
because it ensures that my critical data is always safe, regardless of what happens to the containers.
Right.
And I imagine this also simplifies things like backups and data management.
Absolutely. Data volumes make it so much easier to manage that persistent data for your containerized applications.
Okay, now when we're talking about multiple containers working together,
Right.
it can get pretty complex.
Yeah.
The resources that you sent me highlight a tool called Docker Compose.
Right.
What role does that play in all of this?
Docker Compose is like the conductor of an orchestra.
Okay.
Make sure that all the different instruments,
Yeah.
in this case our containers, are working together in harmony.
Okay.
Docker Compose, you can define your entire application stack in a single YAML file,
Okay.
including all the services, their dependencies, and their configurations.
So instead of manually starting and configuring each container,
Right.
I can define the entire application structure in this YAML file
Uh-huh.
and then just let Docker Compose handle the orchestration.
Exactly. And with a single command, Docker
Oh,
Compose up,
gotcha.
you can bring your entire application stack to life.
Cool.
Docker Compose starts all the necessary containers,
Yeah.
connects them to the right networks,
Wow.
and even handles those dependencies between services.
That sounds really powerful.
It's super powerful.
It streamlines that whole deployment process.
Yeah.
And it reduces the potential for errors.
Absolutely.
And there's more, right?
Oh yeah, there's more. Docker Compose also allows you to scale your application easily
Oh, hey.
by simply adjusting the number of containers for each service.
Wow.
You can manage updates and rollbacks efficiently,
Okay.
ensuring minimal downtime for your application.
This Docker Compose tool seems like a total game changer for managing these complex applications with multiple containers.
It is.
Yeah.
It really simplifies orchestration,
Yeah.
scaling, and that whole deployment workflow.
Now, all this talk about containers and orchestration is really exciting, but it also raises some concerns about security.
Right.
After all, we are essentially running isolated applications with their own file systems and network connections.
That's true.
Right.
You're right. Security is it's a critical aspect of any containerized environment.
Yeah.
The fact that containers run as root by default
Right.
is definitely a valid concern.
Yeah.
If a container is compromised, an attacker could potentially gain root access to the host machine.
Right. So we need to take steps to mitigate that risk.
We do.
What are some best practices for securing Docker containers?
One of the most important steps is to run containers as a non-root user.
Okay.
This principle of least privilege ensures that even if a container is compromised,
Right.
the attacker's access to the host system is severely limited.
So it's like putting the container in a sandbox
It is, yeah,
with restricted permissions.
exactly. And Docker provides mechanisms to easily create and run containers as a non-root user.
Okay, that's good.
So that significantly reduces the potential damage from a security breach.
The resources you sent me also mention another security layer called SELinux.
Right.
What's its role in securing Docker containers?
So Security Enhanced Linux, or SELinux, it's a powerful security module that's built right into the Linux kernel.
Okay.
It provides mandatory access control,
Okay.
meaning that it can enforce very strict rules about which processes can access which resources.
So even if an attacker gains control of a container,
Right.
SELinux can prevent them from accessing sensitive files or system resources on the host machine.
Exactly. SELinux acts as this additional layer of protection,
Oh, cool.
limiting the damage that a compromised container can inflict.
Gotcha.
While configuring SELinux can be a little complex,
Yeah, I bet.
it offers a very robust security solution, especially for organizations dealing with highly sensitive data.
Right. When security is super important,
Yes.
the added complexity of SELinux is worth the peace of mind.
Absolutely.
Yeah.
And it's important to remember that security is an ongoing process,
Right.
regularly updating your Docker images, scanning them for vulnerabilities, and staying informed about the latest security best practices. They're crucial for maintaining a secure containerized environment.
It sounds like Docker provides this really powerful and flexible platform
It does.
for building, deploying, and managing applications, both, on premises and in the cloud.
Right.
But like any technology, it
Yeah.
requires, careful consideration of the security implications.
That's a great way to put it.
Yeah.
Docker empowers developers and system administrators to build incredibly robust and efficient applications.
Yeah.
But with that power
Yep.
comes responsibility
Uh-huh.
to make sure that those applications are secure.
This has been a really enlightening dive into the world of Docker.
It has.
We've gone from, basic concepts to advanced techniques,
Right.
covering everything from Docker files and container networking to data vaulters and security best practices.
We have covered a lot of ground.
What's next on our agenda?
Let's shift gears a bit and explore the exciting intersection of Docker and the cloud.
Oh, cool.
The resources that you shared.
Yeah.
Highlight the growing importance of containerization in cloud environments.
Okay.
We'll delve into how Docker is shaping the future of cloud-native applications.
Nice.
And why it's become this indispensable tool for modern software development.
That sounds fascinating. I am eager to learn how Docker is transforming the way that we build and deploy applications in the cloud.
Let's do it.
Let's dive in. So we've covered a ton in our deep dive into Docker, from the basics of building images to orchestrating complex multi-container applications.
We really have.
Now, I'm really curious about how Docker is making waves in the world of cloud computing.
Yeah, it's a pretty big deal.
One of the articles you shared mentioned how Docker enables cloud-agnostic development.
Right.
What does that mean exactly?
So in the past, when you wanted to deploy applications to the cloud,
Yeah.
it often meant you were kind of locking yourself into a specific cloud provider's platform
Right.
and their tools.
Right. Docker changes all that.
Okay.
By containerizing your application,
Yeah.
you're packaging it in a standardized unit
Okay.
that can run on any platform that supports Docker.
Oh, cool. So I could build my application once, package it in a Docker container, and then deploy it seamlessly to AWS, Azure, Google Cloud,
Yeah.
even my own private cloud.
Exactly.
Right.
This cloud-agnostic approach gives you so much flexibility.
Yeah.
You're not tied to one vendor anymore.
Right.
And you can choose the cloud platform that best suits you,
Yeah.
your needs, your budget, the geographic location.
That's a huge advantage, right? In today's constantly evolving tech landscape.
Absolutely.
Yeah.
Companies need to be, agile and adaptable.
Yeah, for sure.
And Docker just gives them the freedom to move their applications across those different cloud environments as needed.
And this agility extends beyond just deployment, right?
It does, yeah.
Because Docker also simplifies the process of scaling your application in the cloud.
You can easily spin up
Okay.
or down containers to meet fluctuating demand,
Right.
which ensures optimal performance and cost efficiency.
That's the idea.
So if I'm suddenly getting a surge in traffic to my website,
Right.
I can just fire up more containers to handle that load.
You got it.
Wow.
And then when things calm down,
Right.
you can scale back down to save resources.
That's so cool.
Yeah.
Now, when we start talking about managing large numbers of containers in a cloud environment,
Right.
things can get pretty complex.
They can.
The resources you sent over mention tools like Kubernetes and Docker Swarm.
Yeah.
What role do they play?
Those are container orchestration tools.
Okay.
Think of them as the next level of container management.
Oh, okay.
They automate the deployment, the scaling, the networking,
Right.
and even the self-healing of containers.
Self-healing containers. That sounds like something out of a sci-fi movie.
It is pretty amazing. So if a container fails,
Yeah.
for whatever reason,
Yeah.
the orchestration tool can actually detect that failure
Okay.
and spin up a new container to replace it,
Wow.
ensuring that your application stays available.
That's incredible. This level of automation and resilience is so critical.
It is. Yeah.
In cloud environments where applications need to be highly available
Right.
and fault tolerant.
Exactly.
Mm-hmm.
And orchestration tools like Kubernetes and Docker Swarm, they just provide a whole wealth of features for managing complex distributed applications in the cloud.
Yeah.
They handle everything.
From load balancing
Yes.
and service discovery to rolling updates,
Right.
security policies.
It's a lot.
Wow, this is all just incredibly fascinating.
Yeah.
Docker has really opened up this whole new world of possibilities for building, deploying, and managing applications,
You really have.
both on premises and in the cloud. It's
Yeah.
a fundamental shift in the way that we approach software development.
It really is. And you know what's really cool?
What's that?
Docker has democratized access to these powerful tools and technologies
Right.
that were once only available to
Yeah.
huge organizations
Yeah.
with massive resources.
Right.
Now, startups,
Yeah.
individual developers, even students, they can leverage the power of containerization
That's so cool.
to build and deploy these innovative applications.
That's awesome.
Yeah. It's really amazing.
So what's the one key takeaway you would leave our listener with as they're embarking on their Docker journey?
I would say just embrace the power of experimentation.
Okay.
Don't be afraid to get your hands dirty.
Yeah.
Try things out.
Right.
Learn from your mistakes.
Yeah.
The beauty of Docker is that it's relatively easy to set up
Yeah.
and just experiment with.
I love that. It's all about diving in,
Yeah.
exploring, pushing the boundaries of
Yeah.
what's possible with this really cool technology.
It is cool.
Well, I think we've reached the end of our deep dive into Docker. It's been an amazing journey,
It has.
and I hope you found it as insightful and inspiring as I have.
I've had a blast.
Me too.
It's been great exploring the world of Docker with you.
Until next time, keep exploring, keep learning, and keep that tech curiosity burning bright.